This project is called the Dominos and Weebles project. The goal of this project is pretty simple. We're going to set up a series of dominoes standing upright, and then we're going to topple over one of them and have that one domino knock over all the other dominoes in a cascade sequence. In addition to the dominoes, we're also going to be including a marble in our cascade sequence, as well as an object that is not a Weeble but behaves much like the Weebles toys. If you're not familiar with Weebles, they're an old science toy that was designed so that whenever somebody knocks it over, it just kind of wobbles back and forth until it resumes its upright position. You'll notice on my screen, I've included the table from one of the previous projects. My goal here is our domino cascade is going to start off on the table, and then it's going to fall off and continue the cascade on the floor. Now we have two different options that we can follow in order to animate our domino cascade. One of the options is to animate each domino by hand, moving them individually as they topple over and then knock the next one over in sequence. That's going to be very long and time consuming and very much not the way we're going to do this. The other way is we can start the sequence ourselves, but then use the built-in physics engine within 3ds Max in order to calculate how the cascade happens. That's definitely what we're going to do. So a couple of things to note about that physics engine. 3ds Max uses the MassFX physics engine. The MassFX physics engine is a derivative of the PhysX engine created by NVIDIA. PhysX is the same engine that you'll see used in both Unity and Unreal for their physics simulations. Now, if you are familiar with Unity and Unreal, you'll know that the basic unit of measurement in them for distance is measured in meters, whereas the weight is usually measured in kilograms. 3ds Max, on the other hand, if you're using all the default settings, the unit of measurements are in inches, and the mass is in kilograms. This does mean that we are mixing metric and imperial. Sorry. And to head off the person that's having an aneurysm right now because I said that, yes, the units are relative. However, in the physics simulation, those are the measurements used. So unless you want to avoid problems with parallax, you should definitely keep that in mind. And to stop the physicists among you from having an aneurysm, yes, I do realize that mass and weight are not technically the same thing. However, if you want to argue that, please take that up with NVIDIA, not me. Now again, knowing these measurements is important because of the concept known as parallax. Let's show you that real quick. So what I'm going to do is I'm just going to add two objects here. Let's start off with, let's just go for box. And I drew that on the wrong side. Now I'm just going to clone this box and drag it in the background. The way I cloned that was I held Shift and I just dragged along the axis. That automatically brings up a copy of the object for you. Now if I rotate this, I've got both objects visible. However, when I pan to one side or the other, you'll notice the one in the back moves across the screen slower than the one on the front. This is parallax in action here. This is what we're talking about. It's just an illusion that's created simply because of distance. So even though this is usually talking about the observer's movement on two stationary objects, motion parallax can also be seen when objects are in motion, when the objects you're observing are in motion and the observer is still. And when we're dealing with scale in a physics simulation, if your scale is too big, something that you'll notice is that whenever the object is falling down, it'll appear to move in slow motion. And that's, again, just the parallax effect happening. So let's go ahead and begin our project. So first things first, let's get rid of the things I'm not using. And then what we need to do for this first video is just model our domino, model our Weeble, and go ahead and model our marble. All of these are very simple shapes. If you want something more advanced, I've got my previous videos, follow along with them. All the techniques we learned in the chess video and in the dice, donuts, and root beer videos, um, you learn them and you can model basically anything you want. In this video, we are just focusing on the physics, so everything is simple as far as the modeling and texturing goes. So let's begin with our domino. So I'm going to go to Extended Primitives, and I'm going to grab a chamfer box. I'm choosing a chamfer box because if you've ever played with dominoes, if you looked at dominoes, you'll notice that the corners of the dominoes are kind of rounded, and the chamfer box is a box that's defined by its rounded edges. So I'm just going to add a box in real quick, not worrying about the precise measurements when I add it in because I'm going to go to the modifier tab and do some type in values. If you look it up online, you'll notice that most of your dominoes are going to be, so they're going to be 2 inches by 1 inch by, let me think, I think it's 0.375 inches for the thickness. We'll have to double check that. Yeah, 375 is correct. And now I'm going to hit Z on the keyboard with this viewport here. That zooms me in. This one, and this one. Again, Z just zooms you in closely and on whatever object you currently have selected and kind of centers it up in your viewport like that. For the fillet, 0.5 is definitely too much. I'm going to decrease this down. I want to say 0.03 is probably going to be about right for a domino. Now that's one measurement that I cannot find online real quick. After that, our dominoes. Typically, the front and the back are straight flat, and the rounded corners are only along the corners for the short side. So I'm going to add an edit poly now. I'm going to grab vertices. I'm just going to box select all the vertices on the top, grab my scaling tool, and just scale down like that until it's flat. And then I'm going to do the same thing on the bottom. There is that. So dominoes now got rounded corners and flat top and bottom. Now the shadow here going on, that's happening because we've only got one smoothing group for the entire domino. And I'm just going to do polygon selection, and then just do a box selection straight through the thickness of the domino like that. So the only things not selected are the front and back side of the domino there. Now I'm going to scroll all the way down on my Edit Poly modifier and find my selection groups. You'll see that currently all of the selected polygons are on selection group 1. I'm going to turn that off, and I'm just going to put it on a different group, so number 7 is probably good. I click off, and that weird shadow is now gone. Easy enough. The next step of this is going to be our texture mapping. Again, this is going to be fairly easy. We're just going to add an unwrap UVW modifier, which again is right underneath twist. Then I'm going to open the UV editor. My editor comes up on the other screen, so I do apologize about that. We'll go to mapping, normal mapping, change this from back front to box mapping, and then hit OK. And that just unwraps everything for us. So now we've got our front side here, back side there, our 2 long sides, and Either the top or the bottom, haven't really decided yet, and the other one. Now that that's done, if you wanted to texture the domino, you can just export this template out by going up to Tools, then clicking Render UV Template. You'll get this little window right here. Click Render UV Template there, and you'll get this larger window, which again just shows this, but on a black background here. Click Save. And for the file format, you want to make sure to save it as a PNG. And I'm just going to call this Domino Template. And we'll just leave that setting alone. And that's going to save those lines with a transparent background everywhere you see the black, so that you can import this into whatever program you want to work with and just kind of draw over top of where you want the patterns to be. Now for this video, I'm not going to worry about texturing our domino beyond getting it set up. I will save that for a later video. The next step is I want to mess with the pivot point of our domino. So I'm going to add an edit poly to the top of our modifier stack. And then we can see our gizmo here. It's kind of right underneath the domino. I don't like that. I want it to be right in the center of the domino. So I'm going to click on a hierarchy tab right here. And then I'm going to check Effect Pivot Only. So now if I grab my Move tool, I can move the pivot point without moving the domino itself. I'm going to hit Control Z real quick because I notice that this isn't quite at the 0 plane where it should be. It's at 0.005. Really not sure why it's up higher from the 0 plane, but we'll let that go. Now the thickness of the domino is 0.375. In order to get this in the half, we're just going to divide 375 by 2, which is going to be, let's see, 3.75. It's going to be 0.1875. So if I come over to the Z point right here and type 0.1875, press enter. It did round it up on me. We should be okay, but now it's pretty much right in the middle of our domino. I'm going to turn off Effect Pivot Only, so now when I try to do the movement, it'll actually move the domino and not the movement point. Up next, I'm going to grab my Rotate tool, and on the X-axis, I'm going to rotate it by 90 degrees. That'll get it standing straight up. And then I'm going to grab my Move tool, and I'm going to put the Z at 1, which will put the very bottom of the domino on the 0 plane for the Z-axis. And this is going to be important for us later because the 0 plane on the Z-axis within our physics simulation by default is the ground. If anything hits the 0 plane, it's going to act like there's something there regardless of whether or not we set up a collider. That value can be changed in the settings, but I honestly don't see a point in changing the value. You may run into a case where you need to, but for this project, we'll be fine. And I just noticed I've got my MassFX tools window opened up right here. Let me close that out of the way. I'll show you how to open that up in just a moment. Our domino, however, is set up currently. My next step is I'm going to add a MassFX rigid body modifier. So if we scroll down here, we'll see MassFX R body. The R stands for rigid. We click that, we add it in, and that's now applied to it. And you see these white lines here. Those white lines represent the mesh collider that was generated when we added this particular modifier. A mesh collider is just simply an object that's going to be used to calculate when something collides with something else. After that, I'm going to again hold down Shift, drag forward, create a second one. We want this to be a copy. I'm going to delete that MassFX rigid body modifier from the new one. I'm going to make another copy. And then I'm going to hold down Control and select both of them. And you'll see my modifier list disappears, but I can click on it, scroll down, click the MassFX rigid body, and it adds the modifier. It's italicized. When you see a modifier that's italicized, that means that modifier is an instance modifier. So when I click on this object right here, there's the modifier there, there's the modifier there. If I make a change to this one right here, so by default the rigid body type is set to dynamic, I'm going to change it to kinematic, sorry. Click on the other one, and you'll see it also changed there. I'm just setting it right back to dynamic. We'll deal more with this modifier later, but this is our basic setup for our dominoes. This one right here is going to be our starting domino, so its rigid body is not italicized because we don't want it to be an instance, because this one domino is going to be different from all the rest, while these other dominoes, we've got various settings that we want them to be the same regardless of what happens. So up next, I want to go ahead and create our not Weeble. So click the Create Object tab, and we're going to go back to Standard Primitives, and we're going to select Geosphere. We're just going to add our sphere in right there, and set our radius to, let's see, 1. 1 sounds right. One moment. Yeah, I think I'll just stick with 1. All right, so now I'm going to go to the Modifier tab. I'm going to add an Edit Poly modifier to this. Vertex selection, I'm just going to do a little box right across the top like this. For those of you not familiar with Weebles, they are kind of egg-shaped. So we start off with a circle. Then I'm going to turn on soft selection and decrease my fall off here. We've got a rainbow pattern there, right about halfway. And then you just kind of drag it up. And that gives us our egg shape. After that, I'm going to turn off vertex selection. Drag this up right there. So the Weeble is now set on the ground. And then I'm going to add let's add a UVW map. I'm going to change it from planar to cylindrical. So this is going to use a cylindrical projection to determine what the texture map of this object looks like. So if you want to paint a character onto your Weeble, you can. Again, that is not something I'm going to deal with in this particular video, but we're set up for it. After that, we're going to add a MassFX rigid body modifier. We're going to leave all that stuff alone. We will change those values later. And then I'm going to go to the hierarchy and select Effect Pivot Only. So there are a couple of ways we can determine where the center of gravity is on an object inside the MassFX engine. Actually, let's go back to the modifier and show you those. So I'm going to scroll down here all the way to the bottom. In the Advanced tab, usually it'll be collapsed when you first add the modifier. If you click on that, you'll see all of this, and down here is Center of Mass. 3 different options here. Calculate for meshes just basically looks at all of the external points of the mesh and then uses those as reference points and averages out every single one's position. And whatever the average of all the positions of the external points are, that becomes where the center of mass is, which would usually put something on an egg shape someplace right about here, just slightly above where it started off when we have the circle. Alternatively, you can use the local offset right here, where you can just type in exactly where you want the center of mass, or the one I prefer, which is use pivot, and this will just use the pivot point to figure out where the center of mass is. So now if I go to the hierarchy tab, select effect pivot only, I can grab my center of mass here, drag it down here, and the way a Weeble works is because the center of mass is so low on the object, anytime that it gets knocked over, it tries to get the center of gravity as far down as possible, causing it to kind of wobble back and forth until this point comes back to here, making it standing straight up again. We'll get to see that in action in one of the future videos here. So our Weeble's done, our Domino's done, and one more object to make, and that's going to be our marble. Out of all the objects, this one's going to be the simplest to make. Select Geosphere, add it in, set your radius to, let's say, 0.25 maybe. Now let's go 0.5. Well, that's a 1-inch wide marble. That's a pretty big marble. On a Google search, my first guess of 0.25 was actually correct for the average size of a marble. All right. So there's our marble. So 3 objects. We have a marble, some dominoes, and a Weeble. And that's going to be it for this video. In our next video, we are going to be working on setting up a domino cascade, adding forces to our marbles, and basically just starting the whole simulation process in order to get our video done.